All right, we're now on to lesson number 6 from the combinations chapter. And lesson number 6, we will be covering the binomial theorem. All right, so before we get started with the binomial theorem, let's do a few warm-up problems. So let's expand the following binomials. So if I have, remember binomial means you have two terms. So x plus y to the power 0, well, anything to the power 0 will be 1. Then I have x plus y to the power 1. How do I expand that? Well, anything to the power 1 is just going to be itself. So this will be x plus y. And you could write this as 1x plus 1y. And then I have x plus y squared. So if I expand that, I get x plus y times x plus y. And then I want to FOIL all the terms out. And if I do that, I'll get 1x squared plus 2xy plus 1y squared. And if I expand this guy out, x plus y to the power 3, that means I'll have 3 terms, 1, 2, 3. I'll multiply through, I get x plus y times, this expression right here, x squared plus 2xy plus y squared. And then I want to FOIL this again, and once I do that, and once I collect terms, I'll get 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. All right, and moving on to x plus y to the power 4, I get 4 terms, 1, 2, 3, 4. I can definitely expand it, and if I expand it one more time, I'll get 1x to the power 4 plus 4 times x cubed y plus 6x squared y squared plus 4xy cubed plus y to the power of 4. So I think you get the point after expanding these. These aren't too hard to expand and simplify. And so for the last one, I'm just going to give you the final answer. And I'll get something like this. So a lot of terms in my final answer here. Now, one of the reasons why these coefficients have been highlighted in red is because these numbers actually come from the Pascal's triangle, which we covered in the previous lesson. And we also know when we're dealing with Pascal's triangle that these numbers represent combinations. So we're going to be using Pascal's triangle and the binomial theorem in order to expand binomials. All right, so let's take a look. What is the binomial theorem? So when we're expanding a binomial in the form of x plus y to the power of n, we can use Pascal's triangle to determine the coefficients of each term. Okay, so here are some basic rules. Use the exponent n to determine which row in Pascal's triangle to use for the coefficients. The first term must have a power of x to the power n, with the x variable descending in degree by 1. In addition, the first term will have y to the power 0, and anything to the power 0 will just be 1, with each term going up in degree by 1. And a simple little side note here, for every nth power, there will be n plus 1 terms. Okay, so there's definitely a lot of rules there. So let's try to apply all these rules to a simple problem. So I need to expand the following binomial, a plus b to the power of 4. All right, so rule number 1 states that we use the exponent n to determine which row in Pascal's triangle to use for the coefficients. All right, so in this case, n equals to 4. So n is the exponent, and my exponent in this case will be 4. So n equals to 4, so use the 4th row in Pascal's triangle. Here's Pascal's triangle right here. And there is my 4th row. My 4th row has the numbers 1, 4, 6, 4, and 1. All right, so my coefficients will be 1, 4, 6, 4, and 1. All right, so when I expand a plus b to the power 4, these are my coefficients. All right, so that part's done. The first term, so this will be my first term, must have a power of x to the power n, with the x variable descending in degree by 1. All right, so I need an x to the n in my first term here. So I guess my x in this case will be a. So I need to have a to the power of 4. And hopefully that makes sense. This a represents this x, and the n is simply 4. And then basically the x variable will decrease in degree by 1. So I don't have an x variable, I have an a variable, which is this term right here. And so this will actually go down in power. So if I have a to the power 4, then the next term will be a to the power of 3, a to the power 2, a to the power 1, and then a to the power 0. So there it is, a to the power 3, a to the power 2, a to the power 1, and a to the power 0. So I've correctly applied the second rule here, where the x variable will go down in degree by 1. So 4, 3, 2, 1, 0. In addition, the first term, which is this guy right here, will have a y to the power 0. So I don't have a y here, I have a b, so this will be b to the power of 0. And then with each term going up in degree by 1. So if this is b to the power 0, then for my second term, this will be b to the power of 1. And this guy will be b to the power of 2, b to the power of 3, and finally I have b to the power of 4. Alright, so and for the side note here, for every nth power, so in this case my nth power is 4, there will be n plus 1 terms. So if my value of n is 4, then I should have 5 terms in this problem, and I do. 1, 2, 3, 4, and 5. Alright, so that's the binomial theorem. So basically we'll be getting the coefficients 1, 4, 6, 4, and 1 from Pascal's triangle, and then we need to follow these simple rules, rules 2 and 3, and we should be able to get the full expanded form of a plus b to the power 4. And this is actually a little bit quicker than expanding this whole thing out. Alright, so let's take a look at a few more examples. Practice. Expand the following binomials. Indicate how many terms there are and what is the coefficient of the term with x to the power 3. Alright, so we want to expand these binomials here. So x plus y to the power 6. So in this case, n equals to 6, which is the exponent. So that means there will be 7 terms in the expansion. Alright, so in order to find the number of terms, the terms will be found by n plus 1, since n is 6. 6 plus 1 means we have 7 terms in the expansion. Alright, so 7 terms, so 1, 2, 3, 4, 5, 6, and 7. Now we want to use the 6th row because n equals to 6. That means we need to use the 6th row in Pascal's triangle. So here's Pascal's triangle right here, and there is my 6th row. So my coefficients will be 1, 6, 15, 20, 15, 6, and 1. So I can simply insert those coefficients into my terms above here. Alright, so that matches the coefficients in the 6th row. Alright, now we need to find the missing x and y terms here. So if this is 6, then the first term will be x to the power 6. Then we'll go x to the power 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, and x to the power 0. And also for the first term here, I need to have y to the power 0. And then my y powers will go up by 1. So y to the power 1, y to the power 2, y to the power 3, y to the power 4, 5, and 6. Alright, and then we can just simplify this, and this will be our final answer right there. So 1 times x to the power 6, that will be x to the power 6, and y to the power 0 is simply going to be 1. So this is my expanded form of x plus y all to the power of 6. Alright, let's move on to this example below. I have x minus y to the power of 3. And we may want to write this as x plus close bracket negative y close brackets all to the power of 3. So since n equals to 3, there will be 4 terms in the expansion. So remember, the number of terms is found by n plus 1. So n is 3. So 3 plus 1 is 4. 1, 2, 3, and 4. 4 terms in the expansion. We want to use the third row in Pascal's triangle because n equals to 3. So there is the third row there. The third row has 4 terms, so we will use these coefficients into my expansion right here. So this will be 1, 3, 3, and 1. Right, so those are their coefficients. And then for my first term here, I need the variable x to the power of 3. And then I'll have x to the power 2, x to the power 1, and x to the power of 0. Going back to my first term, the y will be y to the power of 0. Make sure we put the y in brackets with the negative sign. Over here, I'll have bracket negative y to the power of 1, and then bracket negative y all to the power of 2, and finally bracket negative y to the power of 3. And once we simplify that, we will get x cubed minus 3x squared y plus 3xy squared minus y cubed. Right? So over here, if I have this negative y all squared, that will just give me a positive y. The negative now becomes positive. All right, so let's move on to another example. Before we move on to some of the other examples, let's try expanding binomials using combinations now, because in Pascal's triangle, those are all directly related to combinations. So each term in Pascal's triangle is a combination n choose r. N is the exponent of the binomial. R is the order of the term starting with r equals to 0. So the first term, r is 0. The second term, r is 1. The third term, r is 2. And when we're expanding a binomial, we can use the formula to find the expression in each term. So there is a special formula that we can use to find any term in the binomial expansion. And this is my formula right here. All right, so if I want to find like the third term, then I can use this formula right here. So instead of expanding the whole binomial, this little formula here will help me find the individual terms. All right, so in order to use this formula, we need to know the value of n and we need to know the value of r. And just remember, r comes from, if you want to find like the second term, for example, then r is simply one number less than the second term. And we'll practice this in the next few examples. All right, let's expand the following binomials using combinations. I have 2a plus 3y to the power of 3. So I want to expand that now using combinations and not using Pascal's triangle. So since my exponent here is 3, I still have 4 terms, 1, 2, 3, 4. Now the first term here will be 3 choose 0. So this is my 3, so 3 choose 0. And then basically when we're using combinations, I'll go from 3 choose 0 to 3 choose 1. Then this will be 3 choose 2, and this will be 3 choose 3. All right, so let's move on and fill in the rest of the terms here. This will be 2a to the power of 3. So once again, you just treat the 2a as an x variable. And since 3 is your exponent, I have 2a all to the power of 3. Then I'll have 2a to the power 2, then 2a to the power 1, and 2a to the power of 0. All right, so that takes care of the 2a. And what about the 3y? Well, for the y's, I'll have 3y to the power of 0. And after 0, we're going to increase the powers by 1. So I'll have 3 plus 3y to the power of 1 in my next term. Then 3y squared in my third term, and 3y to the power of 3 in my last term. All right, now that we've kind of written out the expansion here, I need to simplify this now. 3 choose 0 is 1. 3 choose 1 is 3. 3 choose 2 is 3. And 3 choose 3 is 1. All right, so 2a to the power of 3 is 8a cubed. 2a all squared is going to be 4a squared. 2a to the power 1 is just 2a. And 2a to the power 0 will just be 1. Anything in the power 0, like 3y to the power 0, that will be 1. This will be 3y. This will be 9y squared. And for this guy, this will be 27y cubed. Now, once we've kind of multiplied and simplified all this, we can simplify everything one more time. And this is my expansion right here. 8a cubed plus 36a squared y plus 54ay squared plus 27y cubed. All right, let's move on to the next example here. Find the 17th term in the binomial expansion. All right, so for this example, I have a 20 here, and I don't want to write out all the terms. In this case, I have 21 terms because n is 20, so the number of terms will be n plus 1. I could write out all 21 terms and then find the 17th term, and that would be my answer. But if I did that, that would take a long time. Instead, if you're just trying to find an individual term, you can use the formula from the previous slide. We know n is 20, so for the 17th term, r will be 16. So, I want to use this formula right here. Let me just rewind the tape a bit. I want to use this formula right here. TR equals to n choose r times x to the power of n minus r times y to the power r. So if I can use this formula right here to find any term in the binomial expansion. All right, so in this case, we know n is 20. And then for the 17th term, we want to find the 17th term. We know that r is 6. R is 16. Now, how do we get this 16? Where does this come from? Well, if I look at my previous example here, this 2a plus 3y cubed, let's take a look at my first term. This is my first term here. And for my first term, the value of r was 0. In my second term, the value of r was 1. In my third term, the value of r was 2. And for my fourth term, the value of r was 3. Now, if I went all the way up to 100 terms, then the value of r would be 1 less than 100, which is 99. Now, this example, you can't really go up to 100 terms. I'm just kind of making up a simple example there. But once again, if you have like your third term, for example, the value of r will be 1 less than that term, which will be 2. So if we're looking for the 17th term in this problem, then r will be 16. All right, so we know what n is, we know what r is. Let's find the 17th term. So T16, because this is TR and r will be 16. So this will be 20 choose 16, n choose r, times x to the power of n minus r. And in this situation, the x is simply everything that's touching the x, so 2/3 x. So 2/3 x to the power of 20 minus 16, which is 4. And then for my y term, I have a 3/4, so 3/4y, all to the power of 16. And once again, the 16 is simply the r value. Now, once you've kind of put the numbers into this formula, you just need to simplify it. 20 choose 16 is 4,845. 2/3 x to the power 4 will be 2 to the power 4, 3 to the power 4 times x to the power 4. And 3/4 y to the power 16 will be 3 to the power 16 divided by 4 to the power 16 times y to the power 16. And after that, you guys simplify it one more time, and when you do that, you'll get something like 9.591995 x to the power 4 times y to the power 16. All right, let's move on. The last question for this lesson. Which of the following is the correct coefficient of the term x to the power of 3? Okay, so which of the following is the correct coefficient of the term x to the power 3? Okay, so we need to find the term that has x to the power 3. Now, if we expanded this, the first term would have 6x to the power of 5. And then the second term would have 6x to the power of 4. And then the third term would have 6x to the power of 3. Okay, so with the exponent of x decreasing from 5, x cubed will be the third term, which is exactly what we just talked about. So for the third term, r will be 2. R is always 1 less than the term value. And then we can use our formula, tr equals to n choose r, x to the power of n minus r times y to the power of r. So this will be t2 because the value of r is 2. 5 choose 2 times 6x to the power 3. And this is essentially your x variable right here with the coefficient of 6. So 6x to the power of 3. And then we're going to have our y term, which is negative y over 2, all being squared. All right, so that will be 10. This will be 216x cubed. This will be y squared divided by 4. You do a little bit more simplifying here. 10 times 216 x cubed divided by 4, and then you'll get 540 x cubed y squared. So here's my x cubed term, and the coefficient in front of x cubed would be 540. So the answer here is 3. All right, so that concludes this video, and we'll see you again for the probability chapter.